Number of blue paths. Okay, so there's a tree, consists and point. The good path is a simple path. Starting at any point has the same value. Alright, so this value is the same. It has the same value, and since it's a single node, there is also a path, right? Alright, so Alright, see problem 3. Each element is non-decreasing. Calculate the good index. And that is non-increasing. Where is non-decreasing? What kind of what's the idea? No, we can sliding window here, and we will get it. This is not this is a correct path, and when we add value, still be so let me sync. Right, there is the pointer. First jump non-increasing group, non-increasing, and then jump non-decreasing group. Calculate the index in the group. Alright, so from this position, wait, I think it's not a good idea. Because I have another idea. Because first pass from left to right. And we just calculate the decreasing, k decreasing, and mark as true. So in this example, we get this window. This is good. Maintain a K window. So let's say first this is decreasing, right? and this is decreasing. And this is decreasing, and this is not decreasing. Okay, so we do a two pass. Okay, let's consider left to right. We add the index 30 array. 30 array. This is non-increasing index, and then okay, sorry. Okay, so index is empty, or this value or this value is greater than the now this index back. Alright, so now in this example we made this value to true, right? And so else while is increasing. So alright, so still need a visit array. Index the size is greater than k, so last is going to be L1. And I still need another index the back. This should be the same. So while index back add 1 is equal to I, we are going to do this. Otherwise, it's not equal to I. Okay. Now let's do another. Pass is for from right to left. We still do decreasing. So if index max -1, it's alright, wait. We can just do reverse the nouns. And do it again. Alright, so alright, let's what is the count? Count value is equal to 2. This is well. Return value in the function to time. Oh, answers is the answers the letter array. So if BCI is 2, sorry. Yeah. Oh. Okay, I forgot to add. If index the size is greater than k, visit I plus 1. Okay, so dirty. Yeah. Hmm? Right, so what? In the first example, we add. What is? Oh my god! This wastes a lot of time to. Let's see, probably. You give an array names, return a height consists distinct positive. Ascending order. By the height, right? Alright, so vectors order and sort. Sorted based on the height. Decreasing, right? Decreasing, so it's order pushbacks the inside. Alright, that's problem 1. You given an integer nonce and their size. Consider non-empty subarray. Want to maximum possible bitwise n. In other words, let k is the maximum value. Length of the longest such that subarray. So maximum bitwise order of a subarray is 3. So longest subarray bitwise n. Right, longest subarray. Feel tired. We need to calculate what is the maximum bitwise n. Subarray bitwise n maximum. Alright, so we add number. If the bitwise end is 3, we add it this one. Oh, okay. It's not a 3, we add it. Hmm. Alright. The maximum longest subarray is that has maximum bitwise end. Alright, so what is the maximum bitwise end? It's always a single value, right? Okay, idea is find the maximum value and calculate the maximum value length. Next elements. So 2-pointer. Alright, so okay. Would yeah. Now in this problem, you need to think, what is a good? Okay, so okay, so say if this is if this back is true, say that. What is the number? What's the number? So you say 2, right? So number 2 will add 1 because we have wait. This guy is true. So we will add this I position. So we may add 2, we may add 3. when we push a value, if the back is the same, right? If the back is the same, it means if this value I is equal to the last value at 1, so size is greater than k is I at 1, then push it. So we can simplify to this. Okay, so so like okay. So yeah, that's the idea. Maintain a sorted. It's a 5. So I miss one because if this is increasing, we add increasing value, right? So if this guys, we need when we add this bitch, it can be a 10. So we can add left, we add I, and right, we add reverse term, and what is this? This is going to be true, and wait, okay, so if index back at 1 is equal to I, but this is not equal, right? So still need to check this. Still need to check this. And we clear, and we pop out a value. Yeah, so we still need this. We still need this, the first index here. Yeah. Wasted a lot of time to debug. Okay. Yeah, so that's as a stake. Yeah, that's as a stake. Okay, and yeah, 2 pass. Alright. That's problem true. Yeah, this problem a little hard, but it's straightforward. Alright, so let's consider problem 4. Alright, so girls find number of distinct good paths such that the start and the end node is the same value, has the same value, and what? And the path between this value it's smaller than no. So what should we do? It's a tree, right? So it's a tree. It's a tree, and okay. So in this example, we'll say 1 to 1. We have 2, so this is not valid. And this is a valid because we are so don't have any idea. Missing. Given the age and okay. Less than equal. Okay. Now the idea is that if we have three numbers of a distinct path is 3 add 2 add 1. This guy adds 3. This position we add 2. So it's become okay. Idea is that for each node, try to find the rightmost equal value, and we calculate the number. Okay, so step 1, we want to make tree to array. So in this, we will get its 0, 0, 1, 1, 3, 1, 3, 2, and this is 1, 3. If this is become 2, we get alright, so we should 1, and we add 3. This 1. We have 3 as the array, and we just try to calculate it can work, but it's hard to coding. Actually, think it should work. But the problem is how to make a tree. We use your tool, but this example 1, 3, 2, 1, 3. 2, 1, 3. And let's see, it's I'm stuck. Stuck. Alright, so you were to erase that. How do we know the past and occurs now? You were true. It's 1. Okay, we should use instead 1 3 1 1 3 1. We add 2. 1, we add 2, we add 3. Actually, you're a tourist that is. So it's 1. Wait, so I need to think how to flatten the tree to the right. That's the problem, right? I think we are break. Oh, I may have some idea. Not you are sure. Choose the largest value to smallest each value. Calculate the node of tree it has. Because in this tree we have two maximum, right? So we will get a tree, and after that we cut these two. And what is the maximum? Now it's going to be 2, and 2 in this node is 1. We cut, and after we cut, we need to calculate each tree. Alright, so idea is that we can calculate each tree. From the, we cut the tree, we have 2, so 2. So erase them. We will make this not connected. So we are breaking. Okay, so we are breaking a tree and a subtree, right? So, okay, I may have an idea. Is that first we have this value, and because this is the leaf node, so we won't have the children here. So now we got a 2, and 2. If we cut the age that is from 2, we get this 1, 0, and 3. So 0 and 3 becomes separate. Get new tree 0. Choose But it's hard to cut. Use a break. We break a tree. If this is a tree, we break it to this value and this value. And now for each component, we are trying to calculate the maximum. Alright, if we use a subtract, say 1, we add 1, node 1, we add it. And numbers of a node in this is going to be this and this. And when we add a 2, the group will become this will union. So this will be union. And when we add 3, let's say this will be union. This will be union. Let's make group 2. So okay, I may have some idea. It's do we reverse starting? We don't cut the edge. We starting from smallest to greatest, and we union the edge. When we add the edge, we are connected this two. So this example restarted, and start edge. Edge, and we started by what? maximum A values in this we sorted by smallest node in this range. So when we are at the edge, and which alright, so distinct value. So when for this age, we are trying to do is that it's so we okay, so when we find the value, this is smaller than 0, otherwise when we union these two, group. Alright, so that's connected to Y to X. And group Y this value is equal to group first. Alright, so the maximum value is 10. So we don't don't maintain it. If this is not a sin, first, say group X is going to be group Y. Right, so that's a union. Right, so vector -1 and the size groups will push back. The size is going to be values I and 1. So initial. Okay, so answers distinct and alright, so code its number. Get maximum, give you an I. We will return in, give you a vector, give you an age. Notice okay, so if they match, age I is equal to the X. So we are going to do that union. So we are union and we are union is 2. And still need is that a map is a map that's going to be a value and index. Union, and we are calculated for the I the map X. And for index in the root, we are at that numbers of the groups, the index, the second. Yeah, so that's an idea. Yeah, oh, okay. So it's another unified problem. So it took a lot of time to think that. Okay, so alright, so it's some time to solve this problem. Right. Yeah, it's an interesting problem. Yeah, it's an interesting problem actually. Union and age. When union and age, we just calculate the value. How many value in this value is? Yeah, okay. So see you around time. Okay, that's good. All right. Let's go through this full problem. Oh, took some time and stuck in this problem. Right, so the first problem. The first problem is that you just search. You want to find the names and want to start in descending order by the heights, right? So in this example, the height Mary is 180. So yeah, and we sorted by this height. The idea is that we can use just a recurring index of this value, index of this, and this will assign from 0 to -1. This is IOTA function. And now we started by height and the get order. We are pushed back. Okay, starting order. What is the true name in this order? So you get an SI. So that's problem 1. And for problem 2. Okay, so this problem is a little, it's not straightforward. It's want to find the longest subarray with the maximum bitwise end. And you need to consider what is the maximum of the bitwise end, right? And actually you can use greedy because the bitwise end, maximum bitwise end is always be a self, right? If the smallest subarray is the maximum, always be self, right? So maximum bitwise end is always be a one number, right? So we just calculate what is the maximum. And you need to think that if if the maxima bitwise and we are merge adjacent values, and you just observe that this problem can be converted to simple problem because it's just find what is the maximum length with the maximum value, because the maximum bitwise and is always become the maximum value in the array, right? So yeah, so you need to think why this is become the maximum, because the bitwise and it's the both bit should be 1. So if the maximum value that always be the greatest value or always be the largest value. So when we are merging the adjacent maximum, we cannot make this value greater. We always make this value smaller, right? We can always make this value smaller, or we can always maintain the maximum value. We cannot make this bitwise and to be greater than the maximum, right? Greater than maximum values in the numbers, right? We cannot make this to 4 because the maximum is always be 3. We cannot make it to 4. So yeah, so in this idea, we just calculate, okay, so what is the numbers? What is the subarray length with the maximum value? So find the maximum value and 2 pointer to calculate the length, update the length. The length is 0. That means that the current index is not the maximum, so we need to forward. Yeah. So yeah, it's problem 2. And about problem 3, okay. So this problem is a little tricky actually. I like this problem. Yeah, it's very fun. About problem 3 is that yeah, it's another good problem. It's you identify the good index. What is the good index is that there should be k elements before the index, that is a non-increasing order, and k elements after the index, that is the non-decreasing order. So in this example, this value, the kth element is non-decreasing, right? Because they are 2 and 1, and this is 1 and 3, so this is a good. And also, this is also the good because 1 and 1 is non-decreasing and non-increasing, and 3 and 4 is non-decreasing. So what is the idea? We can separate these two operations in separate for loop. We don't do these two kind of things at the same time. That make problem more complicated. So we do 2 parts. First part is that we go through from left to right. We calculate. We are doing that. Is that we are separate this to the group. So for this problem, so this example, we are separate this to group that will make this guys to decreasing value, this guys to decreasing value, and this guys is decreasing value. So we just calculate. So we mark this is okay valid. This is valid because we have two elements here. This is not a valid. Oh wait, this each case is that they are in the close order. They are in another group, but we also have 2 smaller, so this is good. Yeah, so we do this idea and we do 2 parts. We just calculate what is the common index, common mark in this for loop. So yeah, so we are do from right to left to find the non-decreasing, right? So this is non-decreasing, yes. So this is non-decreasing, yes. So this is non-decreasing, yeah. This, yes. So that's this. And what is the index? Index will become this. This should be true. This should be true. This should be true. So we are find the common, right? So this is a 4. This is 2. Oh, sorry. This all guys are non-decreasing. Actually, increasing is increasing. So this guys is merged to the same. So this is good, and this is good. This is good. Yeah. So we find the common is that the index this value has a common, right? It's a 4, the 2, index 2. 0, 1, 2, 3, 4, right? So we are find. Okay, so this index is have in this for loop they are marked as true. In this for loop they are marked as true. So indicate that we must choose this index. So yeah, so that's the idea. And now how do we do? How do we separate the group? It's just like a stake. When we are going from left to right, we just must check that there should be a JSON value and they are decreasing. So we add this. And when we are at this, before we push back the index, if the index if the index in the beginning just before the index are case element, they have already case element is non-increasing. So we can mark this as true. And the edge case is that if they are a new group, but the previous value also have the case elements that is non-increasing. So we should add this mark as true. Yeah, and clear and push back. And let's do the same thing from right to left. We just reverse it. And yeah, you need to remember because we are reversing the index, so we need to calculate original. We want to recover to original index that we can use. We can use n minus 1 minus I. So that's a mass. Let's say this was 2, 1, 0. We want to make this to 0. So yeah, you minus 1 minus I. So that's a reverse. Yeah, so after we calculate how many numbers is 2, we added. Yeah, this still took some time to solve this problem. Yeah. Alright, so okay, about problem 4. Yeah, I like this problem. Well, actually, it's a very hard problem, but okay. So this problem is need to find what is a good path. Actually, a good path is it can convert to the simple problem. In this tree, if we know the nodes, if we want to calculate 3 because 3 is the maximum, so they don't have any constraint, right? So we just calculate okay how many paths. So if consider that if all the values are maximum, the maximum path is 1, 2, 3, 4, 5. Add this guy from this guy to another guy 4. From this guy to another guy has 3. This guy has 2. This guy has 1. So actually, it's like a formula, right? So n minus 1 add to 1. So in a tree, we can calculate the path. We can use this to calculate the path. Okay, so now the problem is that how do we calculate? Okay, so we thinking reverse. If we starting from smallest value, we merge the age. So for example, we add 1. Now we have 2. The answer is 2. The smallest path is use 1. And now we add 2. We will connect this age. And in this tree, we only have 1, 2. So the answer is we will add 1. Now we add 3. We will merge this age. We merge this age. And the tree now becomes 2, 3. So we add 3. Why do we add 3? Because 2 add 1. This formula. So you can use union find to simulate this process. We sorted the age from the based on this value, and we are trying to go through the values from smallest to largest to calculate what is the numbers of good paths that value is 1 or value is 2, value is 3. So yeah, we just use union find. We sort it based on the values, and when we are go through the value, we are union the age that is the maximum value has this value. So we merge this, and we can calculate each subtree how many numbers in this subtrees. We can add separate subtree. If we have 2 subtree, the 3 have separate subtree. The 3 because this is only 1 subtree. In this example, 1 will have 2 subtrees, single node. Now we just calculate the single node how many different roots, and we add the answer. Yeah. So yeah, that's the idea. And actually, union find, we always record maximum values. We don't need to record all the value in this tree. We only record the maximum. So in this node, we only record a maximum and how many maximum in this. So if the maximum is the same, we just add to merge this. Otherwise, we are trying to merge which is the maximum. If y is the maximum, let's reassign the group x to y. And the merge. Yeah, so that's the idea. Alright, so yeah. Okay. Alright, so thank you for watching.